All right, welcome everyone. Today we are heading out on an expedition, an adventure to the very frontiers of logic. We're going to explore worlds of reasoning that go way, way beyond a simple true or false. Let's get started. Just think about that for a second. So much of our world isn't black and white, right? We're constantly dealing with possibilities, with beliefs, with obligations, even with resources that get used up and don't come back. So what if we could build a logic that's designed from the ground up to handle all that nuance? Well, it turns out we can, and that's exactly where our journey is going to take us.
Now, before we set off, we need to get familiar with our field of exploration, and that field is called proof theory. The best way to think about it is like being a detective for arguments. We're not just interested in whether a conclusion is right or wrong. No, we want to know how it's built. We look at every single link in the chain of reasoning to make sure the whole thing is absolutely airtight.
Okay, so our first stop on this expedition is to really understand why. Why do we even need to go beyond the familiar territory of classical true or false logic? What are the problems we're trying to crack? So, here's our expedition map. First, we'll see why we need to go beyond true and false. Then, we'll pack our toolkit. After that, we'll visit two incredible new worlds, the lands of possibility and the lands where resources matter. And we'll wrap it all up with the ultimate quest, the search for one unified system. Look, classical logic, the stuff you probably learned in school, it's a powerhouse, no doubt about it. But the moment you try to use it to reason about what might happen or what someone believes is true, or in situations where you can't just copy-paste a fact over and over again, it starts to creak and groan. It just wasn't built for that. And that is the puzzle we are setting out to solve. All right, no explorer heads into the unknown without their gear. Before we dive into these new logical landscapes, we need to get a handle on the essential tools that proof theorists use to build and analyze these systems. To make sure they're not just interesting, but that they actually work reliably. So, in our toolkit, we've got three main gadgets. First up is cut elimination. Think of this like finding the most direct hiking trail to the summit. No scenic detours allowed. Next is structural theory, which is like taking a messy, complicated draft of an idea and turning it into a clean, simple set of instructions. And finally, proof search. This is our high-tech scanner, systematically hunting for a valid proof, or telling us for sure that one just doesn't exist. And I really want to emphasize that first tool, cut elimination. It's so much more than just a neat trick. Seriously, the experts in this field call it the central point of proof theory. It's that important. When you find that direct, detour-free proof, you learn fundamental truths about what your logic can and cannot do. Okay, toolkits packed, we're ready to go. It's time to explore our first major continent, the vast and really fascinating lands of modal logics. This is the world of what if and what must be. This is where we learn to reason about possibility itself.
Just look at this shift. It seems so simple, but it's incredibly powerful. Classical logic makes statements of fact about the world we're in right now. It is raining, period. But modal logic lets us talk about other possible worlds while staying right here in our own. It lets us say, it is possible that it is raining. That one little word unlocks a whole new dimension of reasoning.
So how in the world do you keep all these different possibilities straight? It could get confusing fast, right? Well, we use this absolutely brilliant technique called labeled systems. You can literally think of them as GPS coordinates for your arguments. Every statement gets a little tag, a label, that tells you which possible world it's true in. It's like building the map of possibilities directly into the DNA of the logic itself, which lets us navigate these complex ideas with perfect precision. And believe me, this isn't just one single logic. It's a huge, sprawling family of them. You've got your basic modal logic, you've got all these other systems, and each one gives you a slightly different set of rules for exploring these worlds of possibility. It's a vast territory. Now for our next destination. We're jumping to a completely different kind of logical universe. If modal logics were all about possibility, substructural logics are about something way more tangible, resources. In this world, statements aren't just abstract truths, they are things you can actually use up. This right here is the absolute key to understanding this new place. In classical logic, if you know something is true, you can use that fact 1,000,000 times in your argument. It never runs out. But in a substructural logic, a premise is like a dollar bill in your pocket. Once you spend it, it's gone. You can't use it again. This one simple change has massive consequences, especially for modeling things in the real world.
So how do you even build such a strange logic? Well, what's so cool is that it's a process of subtraction, not addition. Proof theorists start with a standard, classical logic framework, and then they very carefully remove or restrict some of the basic rules that we usually just take for granted.
This table is basically the recipe book. You can create whole new logical systems just by removing rules. For instance, see the rule called contraction? That's the one that lets you reuse a fact. If you get rid of it, boom, you've created linear logic, where every resource is precious. Restrict a different rule, and you get a different logic, perfect for a different kind of problem.
And just like with modal logics, this approach has given us another huge family of systems. Each one is custom-built for a specific job, whether that's in computer science, linguistics, or even for reasoning about fuzzy, vague concepts. The diversity is just amazing.
So, we've explored the lands of what if and the worlds where resources count. For the final leg of our journey, I want you to zoom out with me. Let's look at the big picture, the ultimate prize that all of these logic explorers are really searching for.
Because the grand ambition here, it's not just to keep discovering and mapping these individual logical systems one by one. The real quest, the holy grail, is to find a universal method, a systematic, almost algebraic way to build a well-behaved, predictable proof theory for any non-classical logic we could ever dream up. It's not about making one map. It's about building the ultimate map-making machine. And this brings us right to the edge of the known map. What this whole field shows us is that logic isn't some ancient, rigid monolith. It's a living, breathing, flexible toolkit that we can customize to reason precisely about pretty much anything. So the real question I want to leave you with is this: what's next? If we can build these custom logics for possibilities and for resources, what other complex, messy, nuanced parts of our reality are just waiting for the right logic to be invented? The exploration is far from over.